fun. Let's do this. Okay. The population of Kenya's elephants in Kenya is 26,500. The population grows naturally, increasing at 2% per annum. Now it says due to the birth of baby elephants. So there is that's only taking into consideration birth rate, and then it's the only death it seems to be considering is, it doesn't consider natural death rate, does it? It just seems to be considering poacher death rate. Does that make sense? Now, show that the population after n years is governed by the formula difference equation 1.02 pm minus 1 minus 100, right? So you can sort of explain your way through this. Well, look, if the population is x, population starts with x, increase x by 2%. And what happens when you increase x by 2%? 1.02x. And then take away 1,000 elephants killed, yeah? And what do we get then? Anybody tell me? 1.02x take away 1,000. And so your population is 1.02x take away 1,000. However, because it's a difference equation, your population in your next year relies directly on the population of the previous year, and hence, sorry, I put another equal sign in there for some reason. Watching my first year is too much. And that's your equation. Is that right? Now, solve the difference equation. Now, what does it mean by solving a difference equation? So this is the first time you're going to do this, okay? So I'm going to, and it actually takes quite a bit, you'll get used to them. They're actually not too bad. So I want a generalized answer. Is that okay with you guys? So what we're going to do is we're going to start off, we have P0. What's P0? Your population to start, anybody? 26,500. Here we go. Now, what we're going to do is we're going to do P1 is 1.02 PM minus 100, minus 1,000. Is that okay? Now, you might think I'll multiply this out and figure it out. But with all these questions in exercise 8C, don't do that. Just do the next one. So what's P2, guys? P2 is 1.02 P1 take away 1,000. Agree with that? And what is P1? Yeah, so I'm going to actually, I'll bring that 1,000 all the way over here, okay? So look at this. It's going to be 1.02 times all the red bit. So it's 1.02 times another 1.02 times 26,500 minus 1,000, yeah? Okay with that? Now I'm going to multiply that out, and you're going to start to see a trend, right? Maybe not now, but by P3 or P4, you'll start to see a trend on the answer, okay? So would you all agree I have what's it, 26,500 times 1.02 to the power 2. I then have minus 1.02 times 1,000. Yeah. Take away 1,000. Agreed? Right. Now, for argument's sake, I'm just going to get rid of this because that they were my workings. Okay. And I'm just going to change. See this first one? Just going to change that around slightly. I'm going to change it around to 26,500 times 1.02 to the power 1. Has anybody seen a trend so far? Any idea any prediction of what you think the next one's going to be? 26,500 times 1.02 to the power of 3, but we need to figure out the rest of it as well, don't we? But that's we've been able to see it. We've been able to see a little trend so far. So for P3, it's 1.02 times P2. I'm going to put the minus 1,000 all the way over here. You'll see why in a second. What am I going to replace P2 with? I have to replace it with all of that, don't I? So you're like, come on, like, what's going on here? So what you mean by a generalized solution, if I ask you for P100, you guys would have to go P1, P2, P3, P4, P5, P6. You'd have to work all the way up to 100, wouldn't you? A generalized solution means I just sub in the number and it gives me exactly what I want without doing all the iterative steps. Does that make sense? So here's what we're going to do now. Okay. So we're going to do 26,500 times 1.02 squared minus 1.02 times 1,000, and then 1.02 times 1,000 minus 1,000. Stop. Now, see this 1.02 on the outside? You're going to multiply that in, and what do I get? 26,500. Got good? Now what do we have here, guys? 1.02 times 1,000, yeah? Next one. Minus 1.02 times 1,000. Multiply by minus 1,000 at the end, not multiply by. You get the gist, right? Now, try and think about this now. Okay? Now, I think we can safely say that our Pn currently is 26,500 times 1.02 to the power of n. However, what are we going to do about this part? Anybody have any ideas? Well, I think I'm looking at a geometric sequence. Think about it. Let's reverse this situation, yeah? Minus 1,000 minus 1,000 times 1.02 minus 1,000 times 1.03. So see the way that could be T1, that could be T2, and that could be, and see the way it matches to P3. So I think for, what? Oh, sorry, it's 1.02. Very poorly drawn. Yeah, squared, thank you. What do you think the next one will yield? I think that would go, see the way it's power 2. I think for Tn or Pn, what happens is I'd have minus 1,000 minus 1,000 1.02 minus 1,000 1.02 squared, yeah? And then it'll be dot 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 minus 1,000. Can anybody tell me? N minus 1. Think about it. T1 had no power. T2 had power of 1. T3 had power of 2. That means that Tn will have power of n minus 1. So that's a geo all day long, isn't it? It's a geometric sequence all day long, this one is. So that's a geometric all day long. And here's what we're going to do with that geometric. We're going to figure it out using the usual. Sn equals A into what's a 1 minus Rn all over 1 minus R. Okay, what's my A value? Minus a grand, yeah. And my R value? 1.02 to the power of n. Okay. On the bottom, 1 minus 1.02. Okay. Would somebody be so nice as to divide minus 1,000 by minus 0.02? Two of them divided by each other. What do we get? Well, 50,000. Is that right? 50,000. Right. Okay. Going to change that to 50,000. Okay. Now, see that 50 grand? You got to multiply them. Look what happens when I multiply them. So what do you think is going on here? Plus 50,000, yeah. Times what? Times what, guys? Anybody? So 50,000, yeah. And then minus 50,000 by 1.02. And now what happens when I take them away from each other? Oh, sorry, not those two. I'm going to take the two of them away from each other. Pn is what? 6,000. Oh, sorry, 50,000 take away. 50,000 take away 23,500. Huh? No, it's not. No, it's not. Look. Times 1. No, I got it. Ready? Estimate the population of the elephants in 5 years' time. No hassle. What can I do? 50,000 minus what? 23,500. 1.02 to the power of 5. And what do I get? I believe it's, I'm hoping it's 24,054. Somebody verify that for me in seconds. You cool? Okay. Now, next thing. 50,000 take away 23,500 to the power of 10. After 10 years, what you get? Anybody? $21,300 and what you know about the population of the elephant population? What you know? It's going down. And here's the deal. Do you see this number here? Any number above 1. See this number here? 1.02. That's a terrible color. 1.02 to the power of n. That's going to get bigger and bigger and bigger and bigger. So what does that mean? As n approaches infinity, 50,000, 23,500 multiplied by an increasingly bigger and bigger number will be 50,000 take away infinity, which means all your elephants are going to die. Is that right? The elephant Pn will get smaller and smaller. And they will die out. Okay. Now, in how many years, the nearest whole number, will the extinction occur, assuming the situation remains the same? Well, this is your standard log equation, isn't it? So what's it? Multiply by 1.02 to the power of n, and you want the population to be, well, equal to 0 or technically bigger than 0, don't you? Well, you can find out when it equals 0, and then any year above that, it's going to be extinct, won't they? So what do we do next? Move this out to your side. What am I going to do with that 23,500? Well, yeah, I'm going to bring it down, divide it. And then after that, a log of your choice. I'll just choose ln because it's handy putting on the calculator. And then what happens to the n? And what happens to the ln 1.02? Divides, yeah. And you can use the table function on your calculator, couldn't you, to have a rough idea when the extinction would be if you really wanted. Throw all that to the calculator and give me an n value, please. Around the 38-year mark, is it? Yeah. By year 39, they're definitely extinct. Happens somewhere in the 38th year. Probably happens before the 39th year. Is that right? Okay, the population of elephants in Botswana is 214,000, and that'll be P of n. Increases by 2%, so 1.02, the population of Botswana, which is 214,000. Okay. Take away the 800. Oh, and that's the old population, so we want is P of n minus 1. Can I get this? Increase your old population by 2% and take away 800. Okay. Now, we're going to P0 is 214,000. P1 is 214,000. 214,000 multiplied by 1.02, technically to the power of 1, take away 800. P2 is going to be 1.02 times this population here. Okay, so it's going to be multiplied by 1.02 again. It's going to be 214,000 multiplied by 1.02 to the power of 2 minus 800 times 1.02, and then take away the 800 at the end. P3 is going to be 1.02 times all of this, and then we're going to take away 100 at the end. So it's going to be 214,000 times 1.02 to the power of 3 minus 800, 1.02 to the power of 3 minus 800, oh not power of 3, power of 2. Power of 2, power of 1, and this one at the end. Now, I think the gist we're getting is very similar to the Kenyan population, isn't it? What do you think PN is? Did anybody get 214,000? 1.02 to the power of n. Anybody get that far? Okay. The next thing you're going to do is you're going to do your geometric sequence, which is going to be minus 800 for me, minus 800 times 1.02. That's your T1, that's your T2, minus 800 by 1.02 to the power of 2, that's your T3, and dot, 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 minus 800, 1.02 to the power of n minus 1. Now, all of this here, we're going to turn into a geometric sequence. All right. So what are we getting here, guys? Minus 800 times 1 minus 1.02 to the power of n. Okay, can somebody give me the answer for minus 800 divided by minus 0.02? What? 4,000. Perfect. 40,000. 40. Okay, 40,000, guys. Here. Okay. Everybody see that? And when I multiply it out, it's 40,000. Take away 40,000, 1.02 to the power of n. All right. Now I'm going to get rid of all that yellow part. And what I'm going to replace it with is this part here. Okay. And so, see that 214,000? I'm going to take away 40,000 from that. And my Pn is 174,000. 1.02 to the power of n plus 40,000. Now what does it want from me in this situation? What can you predict about the Botswana elephant population? It's going to keep increasing forever. So this is going to get bigger and bigger and bigger. Okay, so 1 second. It will continue to grow. Yeah, that's what I have to say. Now start part 4 to this. Part C, is that it there? You've been asked to advise the Kenyan government, you tell them that they must reduce the number of elephants killed by poachers at most K. Find the value of K, show them how you reach this figure. Okay. We're going to go back to the Kenyan government's calculation. Where was it located? We all agree this is where we did it? Does everybody see the value of 1,000? Would you agree that 1,000 is the number of animals killed in Kenya every year? So we're going to go down our calculation all the way to this point here. Does everybody see this yellow point here? Okay, and here's what I'm going to do. I'm going to revisit my calculation. Okay, instead of 1,000, what should I have instead? Minus K, 1.02. You get the gist, don't you? It's K instead of 1,000. Agreed? So, what's the SM formula then? It's going to be minus K, 1 minus 1.02 to the power of n. And then on the bottom, it's going to be 1 minus 1.02. Can anybody tell me what's 1 divided by 0.02? Huh? Is it 50? So by that logic, what's minus K divided by 0.02? 50K, is that all right? So what we're going to have is 50K into 1 minus 1.02 to the power of n. Okay. So this Pn formula now becomes 26,500, 1.02 to the power of n, plus 50K, minus 50K, 1.02 to the power of n. Is everybody happy with the calculation of the new figure, the new equation? No. I'm hoping this is the last question on it. Is this the last part? Oh, just about. You cool with that? Now, what can we say? Can I join the two of these together? See these two coefficients? Could I join the two of them to make this? Can I make them do that? Okay. Now, plus 50k. Okay. Now, the rate of growth. Okay. Would you all agree that this part is always positive? Yeah? What we're worried about is that what happens if this is negative? What happens if the blue part's negative? And what will happen is, see the green part? The green part will make that blue number bigger and bigger and bigger and bigger. So imagine if it started off at, let's say, minus 50. Eventually, it's going to get so large because that n value could go to the power of 100, the power of 1,000. That it basically means that it become a very large negative number, which means your animals will become extinct. So what we're trying to focus on is keeping this number positive or above 0. So we say 26,500 minus 50k bigger than 0. And what happens then? 26,500 bigger than 50k, 50k smaller than 26,500. Divide by 50, and you get a k value less than or equal, by the way, less than or equal to 530. 530 would keep the population steady. Anything below 530, and it would